This video starts with a thank you to a chap called Matt who took some pictures of the guys putting Christmas lights up on George Square in Glasgow about, I think it was about 9 years ago this picture was taken. And he didn't realise at the time, but that's a picture of me in the cherry picker putting the lights in the trees. And after when he realised that it was me, he sent me the pictures, and I'm really grateful. They're good pictures. It's always nice to have stuff like that. So yes, I'm using a technique called stuffing your mouth full of cable ties, which is just the best place to hold them, and looking resplendent in high-vis hangout a cherry picker. So this video is actually about these lights. You see, when you go into a shop and you buy some Christmas lights, you're likely to get something like this. The plug end will vary depending on the country, but you know, this is the typical sort of lights that are sold these days. And the reason that LED lights are made in this style, which is basically, well, hold on, let's get the pen. They basically get the LED, and it's the little LEDs with the conical lens in the end that goes in, and the little anvil with the chip in it, and the other electrode, and the chip sits in there, the little wire jumps over onto the top of the chip, and to actually fabricate the lights, they solder the cable on either leg, and then they put a wee spacer in here, and the spacer is shaped like a little sort of H. And the idea of the little H shape is that leads go in either side, and it keeps them apart, because then they just put heat shrink over the whole lot and shrink it in, and that's basically how they're made. And one of the advantages of that is that it's very easy to make with a machine, apparently. I didn't realise they were made by machine, but there is a video knocking about on YouTube somewhere. I'll try and find it. It was quite hard to find. But it shows a machine literally just producing tons of these lights, and it really is, it's like the LEDs drop in, the wires are presented, and the soldering, double-headed solder iron comes down, solders them while feeding the solder in, and then they go on, and then the heat shrink slid over the end. It's all automatic, and it just means it's a very easy way to mass produce them. So usually in the UK they're sold with these 24 volt, these 31 volt power supplies. Now the reason they're 31 volt is that most of the LED lights these days tend to be white. They tend to be based on gallium nitride technology. If they're the coloured ones, they'll also be using the gallium nitride technology, but the phosphors for the other colours. And they choose the 31 volts because the LEDs are generally wired in series in multiples of 10. And if you put 10 LEDs in series, the combined voltage is about 30 volts. So 31 volt power supply means that the string can just be a nice round multiple of 10. Like, you know, it could be 20 LEDs, 50, 100, 200, 400, and it'll always just run off that 31 volt standard. These are the power supplies. These ones are made by Shangzhou Jutai. And I have to say, I've opened some of their supplies in the past, and the quality is superb inside. The separation is excellent. You know, it really does divide quite decisively between the mains voltage side and the low voltage side in both this type, the fixed voltage type, and the ones with the animated output that swap the polarity to make the two channels of LEDs on two wires animate. The standard arrangement is just the bare heat shrink, and they claim these can be used outdoors, but if you put them outdoors then water does wick up, and because there's DC across the LEDs it causes accelerated corrosion. I think ultimately it's just the cheapest way to make them, and they're not too bothered about the corrosion because that means you're going to buy more LEDs next year and they're going to make lots more money. The other option you have is to get the 240 volt ones from China, which are made using the same technique, and there you go, it basically shows the construction here with that little spacer and the wires soldered on and the heat shrink, but they just run them at 120 or 240 volt, and the slight downside of that is that the insulation isn't thick enough to comply with, certainly not with British standards. There's no proper strain relief, so if these come off it'll leave bare live ends. And again, they rate them for outdoor use, but if water gets up there then it's going to make adjacent you know, conductive objects live ultimately. So not perhaps ideal. However, if you were to go and buy the Municipal lights, you'd end up with something completely different. Here's the sort of the flimsier, thinner, cheaper sets. And the first thing you're going to notice is that instead of, they're quite bulky, you know, instead of just being the thin sleeve, these are quite chunky. And it goes up one step further. You can get the industrialised ones, which are actually my preference for the bigger trees. Much heavier, but they're using, although this is 24 volts as well, it's using mains rated cable, and you also get the 120 and the 240 volt sets that just have the same sort of arrangement. And you'll notice in these that from the end cap, because these are extendable, there's one really thick cover over the LED, and then the ones after that are smaller. And when you go down to the next section, because these are wired as 7 LEDs in each section, then there'll be 2 wires for the power going across, and then it'll start again. And here's a clue. Here's one of the bigger ones, and you can see the resistor inside it. So to show you what's actually inside those, I've got some pictures, close-up pictures I took earlier. So here's the red ones with the thin wires going in. And the construction is this. It's the same sort of construction with the wires soldered on, but the resistor is also soldered onto the LED. But then they've got this plastic sort of cup, and the LED is pushed into the end. And I don't know if it's by design, but they still use the little concave sort of cone LEDs, but it has this strange effect that if you put an LED into resin, it breaks the refractive index and it creates a completely different lens effect. But in this case, it traps a little air bubble, and that does have the effect of creating a lens that fires the light out the side. So when they put the wires on, they then partially fill these little cups up with resin and then push the LEDs in. And I'm guessing that the reason they're tapered at the end is actually to try and grip the LED or something. Not sure. But certainly when the LEDs are pushed in, it displaces the resin up, right? And it's a precisely measured quantity that it won't squirt out the end. Sometimes it does squirt out the end, but in most instances, you know, it's just precisely measured so that it fills it up and it seals completely around the LED. And the wiring, and also acts as a strain relief. And then the strength of these plastic things is quite, you know, they're very strong. Then they sleeve over them. And likewise for the higher voltage, not higher voltage, well, the higher voltage, yes it is, you get the 240 volt version of these. But even with the lower voltage ones, they just have a larger cup for the resin, and the LED is forced in again, and the resin just squirts out the top and it seals it off. And the reason for this is that this absolutely seals water out of these lights, because whereas these ones will corrode inside, and if I put these ones outside for a season, then you'd, at the end of the season, or even part way through the season, literally days into it if it was raining, you'd start seeing rust appearing behind the LEDs. And that might be okay where you can go out, you can get a new set of lights, you can go and hang them in your tree because it's quite accessible. But if you're putting up council lights, then the last thing you want is huge sections out the top of a 30 or 40 foot Christmas tree, because it means you're going to have to send guys out with an aerial access platform to go up there and fix them. So it pays in the long run to have the more robust lights. And likewise, the bigger trees are prone to a lot more movement, and in stormy weather it really snatches and pulls at these strings. It puts a lot of strain in them. And just ordinary strings like these would break, the wires would snap, they'd fall out. These ones withstand incredible amounts of stress from stormy weather. And I've been using some of the, certainly on George Square, some of the sets we used just lasted for a massive length of time. You know, the only reason they were retired was through natural reduction in intensity that happens over time. And also just maybe they changed the colour, maybe they went from, initially they started cold white, then they went to warm white, and then they went to this really lovely tungsten golden white. But they're super, super rugged. Now, there's another type of light we used, and it was in the Monument, and it was the... Oh, I should actually mention before I go any further. The power supplies typically used on this type of lighting were these, fairly standard manufacture TDC. And you get the transformer and it's potted in resin, so it's completely waterproof. It's sealed with a proper outdoor cable, which is the rubber cable, HO5 type cable. And in the original tungsten sets just went straight into the transformer, but latterly, when they switched to the LED sets, they used the same transformers but simply added a box. And this box contains four 3-amp rectifiers. And it also contains 2 little aluminium plates. I never quite worked out what their purpose is, but because they're not electrically connected or thermally connected, it's almost as if it was just to support the case and so on. I'm not really sure. But the most problems I ever had with these sets of lights was with these rectifiers. But fortunately, when we used the lights, you'd string multiple sections together, so you always end up with spare rectifiers, and it was just easy enough to swap the rectifier in. But because there's a DC, because when water got in, because it's DC, it had the really weird effect that when you opened it up to check what had happened, as I did instead of just throwing it away, you'd find that all the tracks had been just dissolved. No sign, no flash or arcing, it had just dissolved away because it's low voltage and electrolysis, it just ate all the copper away. So that's the type of power supply that was initially used, and latterly we got some really good little potted electronic transformers which were more about this size, with the mains and the power going mains and in and power out going on one end and just filled with resin again, and they were actually really reliable. Never ever had one fail. So moving on to the other styles of lights we used, if we were using lights, a mesh of lights, a curtain of lights, instead of using, let's see if I can find one. Instead of using this very flimsy sort of type of light that you get, which is, it's a mesh of lights, but they're just super thin cable. These just would not last outdoors, and if you put too much pressure and you're pulling these into sort of shape or trying to cover an area, get a ceiling of light, the wires will just snap and expose live connections in the case of this one, because it is mains voltage again. But in the case of the municipal lights, we don't tend to use those, the sort of, you know, the zigzag of the wires going into the LEDs. What we tended to use was the power supply, whether it was electronic or with the rectifier, feeding with a modest length cable a bus bar strip. And the bus bar strip was a thick cable, and it had pressed onto it, had little connectors all the way along it. And it also had a connector on the end so you could actually chain a couple of these, but just in most instances it's just 2 you could chain, although you get other systems that let you chain a lot more. And in each of these was you plugged in a string of lights, and the string basically just went down as straight lines. And one of the advantages of this is that if one of those got damaged, you could change an individual string, and you just ended up keeping spares. And we did have an issue with the ones on the George Square monument, whereby when they installed the ice rink round the monument, they sometimes lost control of the panels and smacked the monument, and it chopped the cables. And it doesn't matter where you cut these cables, if you nip one of the cables, you'll lose pretty much the rest of the section from there, or you'll lose the whole string, because these operate a strange system. It's not that strange really. They operate a system whereby the positive is fed from one end, and there's multiple sections of lights all the way down it, and then the negative goes all the way down to the bottom and it's fed from the other end. So if they did just nip off the very last circuit, instead of losing the last circuit, you lost the whole string. And normally people would just replace the whole string, but if you strip the wires at the end, keeping in mind this is low voltage, and you just dabbed, either all the other lights dipped if you got the wrong wire, or that string lit again if you got the right wire, and then you just twisted them together, taped them up, and cut the other wire off. So they were repairable. But the other advantage of these strings is that because they're designed to cover large areas, they tended to be quite long, and the best way I found to work with these was, in the case of this is another sort of dodgy Chinese one, was to roll them up in a ball. You'd basically unplug a string at a time and then just roll it alternately round that way and then round that way into one big ball. And it meant that when you came to next year, you could literally plug it in and drop the ball and it would unravel itself. Or if you're working the cherry picker, you could drop the ball into the basket, and as you pulled the lights out, it would just roll about in the basket, and yeah, you'd kick it about a bit, but it would never really tangle up. Very good way of doing it. That's another reason these lights have to be tough. A abuse they get from the guys installing them. You know, there's no subtlety. It's not like delicate, you know, oh, careful, just put them in the tree in the garden. They really do get thrown about. They get chucked in the back of vans. They get dragged. They get tangled up, and it's just that's where the extra strength just makes these last a lot longer. Now, these lights are a lot more expensive than the cheapy domestic ones, the home ones. I should mention here, when I say domestic, I actually mean to do with the home. So a domestic appliance is an appliance in the home. I know in America, if you say domestic, it actually means to do with America. So produced domestically means made in America. So when I say domestic, I mean to do with your personal home. But the home grade lights are just, they don't have to stand up to the same rigours as the municipal ones. And it is ultimately all down to reliability and, you know, being able to put them up season after season and not have comeback. It's just worth every penny for that. So that is the difference between domestic lights, home lights, and the super rugged municipal ones. I should mention, there's another thing here that's worth mentioning. The resistor in these, in the case of these white ones, the resistor, there's one resistor per section of 7 LEDs. And there's 8 sections of 7 LEDs making up 56 LEDs in a 5-metre section. And these generally, the string comes, in the case of these extendable ones, the string comes as is 5 sections of 5 metres to make up 25 metres, and you can theoretically add another section onto the end of that to make up a 50-metre run. But it's divided into those sub-circuits, and you'll see the 2 wires come out, positive and negative, and then it'll go through, there'll be 3 wires where the circuits, the LEDs are all looping through, and then after 7 LEDs it'll be down to the positive and negative again, and then it'll start the next section where there's 3 wires. And each one starts with that, in the case of the white LEDs, it's got 1 resistor, which the colour is orange, white, black, black, which is it's 4-bar colour code. So it's 390 and 0 multiplier, so it's 390 ohms in this case. On the red LEDs, they had a different arrangement. In the red LED, for the red LEDs, because the forward voltage of the red LEDs is lower, they'd actually start each of the sections. So there's the 2 wires. They'd start it with the first 2 holders would have a resistor in them. In the case of this one, let's see if I can actually read this off this. The colour code was orange, orange, black, black, so 330, giving a total of 660 ohms in series. And these were also wired differently. Instead of being 8 sections of 7 LEDs, these are 7 sections of 8 LEDs, so they add up to the 56 LEDs again. And that just allows for the fact that there's a slightly lower voltage. More is being dropped across the resistors, and to spread the dissipation, they just put more resistors in each section. Likewise, if you had the 240 volt version, it would have been 56 LEDs in series with this same heavy double insulated rubber cable. And if you do the maths, with 56 LEDs times roughly 3 volts would give 168 volts, meaning on the standard 240 volt supply you'd have about 72 volts to drop across the resistors. So to spread that dissipation on the 240 volt ones, it was either a resistor in every single cap, or you'd find every second cap would have a resistor in it, and it would alternate between large cap, small cap, large cap, small cap, all the way along. And that would just spread the dissipation along the whole section. And if you felt them, they didn't really get that warm, you know, it really did spread the dissipation. So that is fundamentally, and it seems such a short video for the amount of research I had to put into that, and getting all this stuff together and taking pictures. But that is fundamentally it. So I notice there's a nasty trend of people buying the cheap lights. I'll show you another set, in fact. Here is a set of what they call Waterfall Lights, and I got these on eBay. And they're from a British supplier, well, a British warehouse anyway, and they come with a square pin plug. And again, the wiring, it's thicker wiring, but it's not what I'd call double insulated. And I got 2 sets of lights from the supplier, and they both came with the control box wrapped in cling film, sticky cling film at that. And I get the feeling that, I don't think it's for extra waterproof, I get the feeling they actually deliberately put this on so that it's harder to take these apart. And it doesn't say anything about taking it off, but it honestly looks like it's been wrapped, and then someone's grabbed this little knob on top and just gone like that and ripped a bit of cling film off. I think that's supposed to be there, and it's a bit tacky. But in this case, you've got the output from the controller going along a string, and it is animated, and then it's got lots and lots of little strings just permanently attached to it as separate little clusters, and each one has a number of resistors in it. And I will say, to be fair to this one, it's fairly small. It's got about 30 LEDs per string, and the resistors in it, they've actually chosen a sensible value, and they've put enough of them in to actually spread the dissipation and stay near the rating of the resistor. It still falls down somewhat in terms of the insulation, particularly the heat shrink, because if you look at this, you can see the heat shrink is pretty stretched there over fairly sharp solder joints, and I've come across some of these that, the solder actually sticks through the heat shrink. But unfortunately, there are people who are trying to get into the market, and they're buying this stuff from eBay, and they're putting it in outdoors, in public areas where kids can touch it. And that's not very good, because it really isn't safe for exposure. It's not waterproof. They're going to have that problem that it's going to corrode and it's going to fail very quickly. So if you do get involved in specifying lights for outdoor use in a sort of situation where it's a more professional situation as opposed to just home use, don't skimp, don't get the cheapy stuff, not even the stuff like this. I mean, you could treat this as disposable stuff, it's certainly cheaper. But if you want to do the job properly, then try and find a professional Christmas light supplier and get the lights from them, because it'll just save you so much grief in the long run, particularly if there's an incident, because if there is an incident, someone gets a shock or something happens, and it turns out you got material from eBay and then used it in a public area, that doesn't act in your favour. So go pro. Yeah, definitely get the professional stuff or the low voltage stuff if you're going to ever put stuff where people can finger it. And that's it. It's an interesting subject. I spent over 20 years doing Christmas lights and have no intention of stopping at this point in time. So yeah, interesting subject. These cheap and readily available, but for that, it's a lot more money, I must admit, for the other ones, but they're worth every penny.